Hey everybody, it's Mr. Oaks. So today, even though this is a new video, it's kind of a review of a previous video. This is constructing functions to model linear relationships, which really what it comes down to is we're writing equations. So it's very similar to my video on writing equations, so think of this just as a refresher. And basically we're going to just look at two things. We're going to look at writing, constructing a function when we are given a graph, and then when we are given 2 points. And really what I mean is we're given values. We can either be given 2 points directly in the problem, or they can give us a situation where we have to pull points from. So what we're going to do first is we're going to look at this here, this graph, and it says the graph of the line represents the cost of renting a kayak. Write a linear function in the form y equals mx plus b to represent the relationship of the total cost c of renting a kayak for t hours. Okay, so immediately I go, aha, write a linear function. Well, that's the same as when we would say write an equation. So this is m equals b equals y equals mx plus b, y equals blank x plus blank. So I'm going to just write that here. M equals b equals y equals mx plus b, y equals blank x plus blank. Now, as always, when we're given a graph, the very first thing I'm going to look for, because it's usually the easiest thing to find, I'm going to look for the y-intercept. So I look, and there's a problem. The line does not intersect the y-axis at a nice spot. I can't really tell what that is. It's a little difficult to see from the camera, but on my grid paper, this point kind of falls in between what is 6 and 8. So I can make the assumption that the answer is 7, but I can't just go with that. I have to have proof. I can't just basically say, well, it looks like 7, so I'm going to put 7. I might be right. I might be wrong. So I need to be sure. So starting off with the y-intercept, unfortunately, not going to be able to do that this time. However, I'm going to look for 2 nice points so I can find the slope. And since I have a graph, I'm just going to do rise over run. Rise over run. So I'm going to look for 2 good points. And when I look, I notice that there's a good point right there at what looks like 110. So I'm actually going to write that. And the cap's going to fall off my pen. Oh well. 110, just so I can keep track of this. And then here's another good point right here, right up here, at what looks to me to be 316. So I'm going to draw my little triangle, and going up, so this is at 10, so 2, 4, going up 6, so our rise is 6, and we're going from 1 to 3, so that's a run of 2. So it looks like my slope is 3. So I'm going to put that in here, 3, 3. So far we got that. Here's the problem. I gotta figure out how to find the y-intercept. And it's actually not that difficult. I have pretty much most of my equation. I've got the 3, and believe it or not, I can use either of these points, 110 or 316, as my x and y. And I'm going to use the smaller one. I'm going to use 110. And what I'm going to do is I'm going to substitute that in to y equals mx plus b. So I'm going to rewrite that over here. Y equals mx plus b. And I've got my y is 10. We already know that our slope is 3. And we have that our x value is 1. The only thing that's missing now is b. So now I can work with this and figure that out. So I got, apparently all the caps are just going to come right off today. 10 equals 3 plus b. I'll subtract 3 from both sides. And I get that b equals 7. Just like I thought it was, but I had to be sure. So I can take that, my b is 7, 7. So the equation for this, I'll hop over here, y equals 3x plus 7. And that's my equation. I don't even know where this cap went. Oh, it went all the way on the other side. All right. So that's our equation. So this now is the really tricky thing. And it's really not that tricky. It's basically just remembering I got to take a point that I know and plug it in. Replace my x and my y with the x and the y from the point. Not difficult, but now it's a new thing. And so it's just a new thing you have to do. Okay? But still, we're able to find the equation with little to no difficulty. The second thing, come back to me. Getting blurry again. I'm going to move this up just so I have some more room. Boom. Okay. Oh, and that helped. So, this time we have a situation. And remember I said that there's 2 points in here. So first we'll read it and then I'll show you where the 2 points are. The deli charges $7.50 for a salad weighing 3 pounds. A salad weighing 4 pounds costs $9. What equation can be used to represent the cost of the salad, y, for X pounds of salad? So, as I said, there are actually 2 points here. The first point is going to involve the $7.50 and the 3 pounds. Did I take my glasses off? Here, Cameron, do you need my glasses? Do you need my glasses for you? Here I am. Here we go. Here we go. Okay. Little tricks. Little tricks. So, the thing to realize first off is we have to figure out what's going to be our x, what's going to be our y. What's our independent variable, what's our dependent variable. So the good question is to say, does the weight of a salad depend on its cost? Or does the cost of the salad depend on its weight? And if you think about it, when you go and buy a salad at like the deli, they're going to weigh it and that's going to determine how much the cost is. So the weight is our independent variable. It's our x variable. So our first point is going to be 3, comma, 750. And then our second point is going to come from here. We've got 4 pounds, cost $9. So 4, 9. Now I did it like this because if you remember from my previous video when we were writing equations, when we're given 2 points, I need to use the slope formula. Okay, so we got m equals y2 minus y1 over x2 minus x1. And when we do this, we have to determine, well, what are my y's, what are my x's, what's my 1, what's my 2. So what I do is I kind of do a little chart. I kind of break up my points. That's why I put them over each other. Everything in the first column is my x values. Everything in my second column is my y values. This is my first point. This is my second point. Now I can go and I can follow this and say, well, y2 is 9. So 9, y1 is 750 minus 750. x2 is 4. So obviously x1 is 3 because it's the only number we had left. When we do our subtraction, we get 1.50 or 150 over 1. So our slope is 1.50. And I didn't write it already, but m equals b equals y equals mx plus b, y equals blank x plus blank, and I'll just fill in 1.50 in front of the x since we know our slope. But now we have to find the y-intercept. Because if you stop and think about it, 1.50 times 4 is not 9, and 1.50 times 3 is not 750. So there's got to be something else going on there. A base charge, if you will, to get a salad. So what we're going to do, we're going to do like we did in the last one. We're going to start off with y equals mx plus b. And then we're going to choose one of these points to substitute in here for our x and our y. And the better one, in my mind, is this one, 4, 9, because we don't have a decimal to deal with. So I'm going to go and I'm just going to start substituting in. Y is going to be 9. Equals. We already know that our slope is 1.50. Our x value is 4. And we're looking for b, so we just have plus b. When we do our work, 9 equals 1.50 times 4. 1.50 times 4 is 6. So we have 6 plus b. Subtract 6 from both sides. We get that b equals 3. So we plug that in, and that's it. There's our equation. Not too bad. Okay. Really, it's all about organization. You're going to hear me say this all the time. That the best thing you can do, the best way to get better at math is to be able to organize your work so that you can figure out what is going on. I hope this video was helpful. If you found it helpful, please like and subscribe. If there are other things you want me to work on, please feel free to comment. I am Mr. Oaks. I hope you have a great day. Keep on keeping on.